In this section, we're going to look at graphing inequalities in two variables. The first thing that needs to happen anytime you've got an inequality in two variables that you are intending to graph is you need to look at the equation that would be the same as your inequality. So here, our equation would be 3x minus 2y equals 8. The only reason we do this is for the purpose of graphing. Solve this equation for y. Now, you're going to have to go back to the inequality, and I'll show you why. To isolate y, you'll have to divide by -2 on both sides. And anytime you multiply or divide by a negative value, your inequality sign changes. Once you have this, you can graph. So we'll start with the y-intercept is -4. The slope is 3/2, so that's up 3. So 1, 2, 3 over 2, 1, 2. So this will be the location of my next point. 2 points determines a line. Now, when we draw this line, it will either be a solid line or a dashed line. The way that you know the difference, if you have this equal to, it's a solid line. If it's not there, it's a dashed line. So in the case of this equation, or this inequality, we'll need to graph a solid line. And I know mine is not perfect, but there's our line. Now, we're told that y is greater than this line, greater than or equal to this line. So now what we have to do is we have to shade the graph, and we shade anything greater than that value. So anything above this line is what we'll shade. What this means is that any point within this region will satisfy that inequality. Here we have a system of inequalities. With a system of inequalities, we're going to have to graph two lines and then shade them both. So first, I will rearrange the first inequality. Then I'll do the second inequality. And then again, when I divide both sides by -1, I change the inequality sign. So my first graph, y is greater than 1 minus 2x. My y-intercept is 1. And with a slope of -2, that means you move down 2 and over 1, down 2 and over 1. So here are my points. With this one, because it is it is greater than, but not greater than or equal to, the line needs to be dashed. Oops. and we shade anything above this. So here's above. Now I'll graph the line that's blue. My y-intercept is -3. My slope is 1, so that means we travel up 1 over 1, up 1 over 1. And because this is y is greater than or equal to, the line can be solid. Oops, there's my point right here. So a solid line and then again I shade above this. Notice where the red and the yellow overlap. This region will be the solution to the system. So this area here is the solution to the system. All right, here's the last system. The first equation is x is less than 6. So if this was x is equal to 6, we would graph this as a horizontal line, as a vertical line at 6. But this is less than. So first of all, it needs to be a dashed line. And then when we shade everything less, that means we shade everything over here. Now, one thing that you should pay attention to is because I've got 3 inequalities that have to be graphed, I'm shading my first section as light as I possibly can. My second inequality, x plus y is greater than 4. So y is greater than 4 minus x. Y-intercept is 4. Slope is -1. That's down 1 over 1, down 1 over 1. And because this is less than, it's a dashed line. And then I need to shade where y is greater than this, so anything above that line will be here. Notice that I am not bounded by that x is less than 6 line, because this pink graph that I drew that I'm shading in green does go past that. Now we'll look at the last one, and it's actually already in slope-intercept form for us, which is helpful. We again have a y-intercept of 4, and I have a slope of -1/2, so that means that I move down 1 over 2, down 1 over 2. And because, again, this is less than, but not less than or equal to, it's a dashed line. And here, we're shading below y. So that means that we shade below this blue line. What you should notice is that this region is bounded by these intersection points that I have outlined in black here. So that very small triangle is the only location where all 3 of these inequalities overlap each other. From here, I strongly recommend that you go and read through section 3.7 in your textbook for a few more examples.